Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized pieces. Today, we're looking at a paper that could change how we make AI smarter, especially when it comes to understanding videos. Imagine trying to teach an AI how to follow a complex video tutorial, say, for building a bookshelf.
Right. The usual way is to make it watch thousands, maybe millions of videos. It's a slow, expensive process called training. But what if you could skip all that? What if you could just coach the AI in real time, as it was thinking about the video?
That's the core idea behind a new paper called Video Reasoning Without Training. It's a method for making AI better at understanding what's happening in a video, not by training it more, but by guiding its thought process on the fly.
So first, let's talk about the problem they're trying to solve. Getting an AI model to reason about a video is a huge challenge. We're not just asking, is there a cat in this video? We're asking things like, based on the science experiment, why did the liquid change color?
Right, the usual way is to make it watch thousands, maybe millions of videos. It's a slow, expensive process called training. But what if you could skip all that? What if you could just coach the AI in real time, as it was thinking about the video?
That's the core idea behind a new paper called Video Reasoning Without Training. It's a method for making AI better at understanding what's happening in a video, not by training it more, but by guiding its thought process on the fly.
So first, let's talk about the problem they're trying to solve. Getting an AI model to reason about a video is a huge challenge. We're not just asking, is there a cat in this video? We're asking things like, based on this science experiment, why did the liquid change color?
Exactly. The AI has to connect different steps, understand cause and effect, and draw conclusions. Current methods often use something called chain of thought. You basically tell the AI to think out loud, step by step, before giving the final answer.
Which sounds like a good idea, but in practice, it means the AI generates a ton of text. It rambles. It's like asking for the time and getting a history of clockmaking. This makes the process incredibly slow and computationally expensive, especially when you're dealing with high-resolution video.
It's a double whammy of cost. The initial training to get the AI to think this way is expensive, and then running it is also expensive because it's so wordy. The researchers behind this paper thought there had to be a better way.
And they started by asking a really interesting question. What does a good thought process inside an AI even look like? To figure this out, they decided to eavesdrop on the AI's internal state, specifically its level of uncertainty.
They measured this using a concept from information theory called entropy. In simple terms, entropy is a measure of surprise or uncertainty. If you ask an AI to predict the next word in a sentence, and it's weighing a dozen different options almost equally, its entropy is high. It's uncertain.
What if it's very confident the next word should be pancakes? Its entropy is low. By tracking this entropy word by word, the researchers discovered a distinct pattern in how high-quality AI models think.
It happens in two main phases. The first is what they call macro exploration. As the AI starts to think, its entropy goes up. It's exploring different pathways, considering various ideas, and its uncertainty about the best path forward increases.
Then it hits a peak, and that's when it enters the second phase, macro exploitation. The AI starts to lock onto what it thinks is the correct reasoning path. Its entropy begins to fall as it becomes more and more confident, exploiting that single line of thought to produce the final answer.
But here's the crucial discovery. The very best, most accurate AI models had a specific twist on this pattern. Their entropy didn't just skyrocket. It rose more slowly, peaked later, and the peak itself was lower than in less accurate models.
That's fascinating. So a smarter AI doesn't just panic and consider a million random things. It has a more controlled, grounded thought process. It explores its options for longer before committing to an answer. It's the difference between a thoughtful detective and a frantic one.
They even noticed tiny little fluctuations during this process, what they call micro-explorations and micro-exploitations. It's like the AI is constantly taking a small step forward, double-checking its work, maybe taking a tiny step back to reconsider before moving on. All of this helps keep its overall uncertainty from spiraling out of control.
Okay, so if you know what the perfect thinking pattern looks like in terms of entropy, the next logical step is to ask, can we force a regular AI to think that way without any retraining?
And that's exactly what they did. They built a system called vReason. Think of it as a real-time coach for the AI's brain. It's a tiny trainable controller that they attach to the AI only when it's being asked a question.
So how does this coach work? It watches the AI's entropy level as it generates each word of its thought process. If it sees the entropy rising too quickly, if the AI is getting flustered, it gives its internal state a little nudge. It encourages it to slow down and embrace those small, controlled microcycles of thinking.
This has the effect of delaying and lowering that big entropy peak, making the model's thinking style mimic that of a much stronger model. Then, once the model has done enough of this deep thinking and its entropy naturally peaks, the coach changes its strategy.
It tells the AI, okay, you've got this. Time to land the plane. It starts pushing the model to reduce its entropy, to become more confident and converge on an answer quickly and concisely.
The most brilliant part is that this is all done without any new data. The coach is just guiding the model based on its own internal state of uncertainty. No expensive, time-consuming training required.
So, the million-dollar question, did it work?
It works spectacularly well. In terms of accuracy, the AI coached by vReason performed almost as well as giant models that had been extensively trained with reinforcement learning, which is a much more costly technique. They closed the performance gap to within 0.6%.
That's a huge deal. Getting almost the same performance without the cost of training is a massive win. But it gets even better, right?
It does. The biggest win was efficiency. Because the vReason coach pushes the AI to be concise after it's done thinking, the final outputs were drastically shorter. The coached AI used 58.6% fewer words, or tokens, than the traditionally trained AI.
Wow, so instead of a 5-page essay, you get a clean 1-paragraph answer. That saves a huge amount of time and computing power. It's not just better, it's faster and cheaper too.
Exactly. They even made a light version that's more memory efficient by intelligently ignoring less important parts of the video, making it possible to run on less powerful hardware.
The big takeaway here seems to be that we don't always need more data or more training to improve AI. Sometimes it's about improving the quality of the AI's thinking process itself. This is a shift from just brute force training to intelligent, real-time guidance.
And it could make sophisticated AI reasoning much more accessible. Imagine an app on your phone that can watch a video of your car engine making a weird noise and, after a few seconds of thinking, tell you exactly what's wrong. This kind of efficient, training-free reasoning gets us a big step closer to that reality.